Hi students, welcome to KTU Web. In this video, we are going to deal with a full stack design problem on riveted joint. Okay, let us dive into this question. Design a double riveted lap joint with zigzag riveting for 13 mm thick plate. The working stresses are given as tearing stress is equal to 80 megapascal, shearing stress 60 megapascal, and crushing stress 120 megapascal. Here we have two kind of data. The first one is the strength of required joint, and the second thing we have thickness of plate T equal to 13 mm. Based on this data, we have to design the rivet. That means you have to find the margin, pitch, transverse pitch, and number of rivet per pitch length, etc. Okay, whenever you're dealing with a design problem, you need a couple of equations, and no need to mug up those equations. You can use any standard data books. In this video, I am depends upon a data book from K Mahadevan. You can use any kind of data book as per your wish, and you have to locate these set of equation in your own data book. And from book to book, there is a slight variation in methods and slight variations in equation. Even though that's the case, you can follow this procedure as a standard to design any riveted joint. Okay, let us start with the step 1. In step 1, we have to find the type of rivets. The type of rivet is already given in the question. I'm recommending you to have a rough sketch at least to identify the type of rivet and to extract certain information which is required to solve this question. Here we have a pretty much good diagram for this particular type of rivet. The type of rivet is given as the double riveted lap with zigzag arrangement. As that name indicated, it is a double riveted, means one plate is overlapped on another plate, and since it is a double riveted, you could have two rivets per plate. And remember, it is a zigzag joint, so that's why we are having a dotted line here, because on this cross section you cannot get that. So that's why we are putting dotted line. That means we are arranging rivet in a staggered manner. One rows of rivet is over here, another is fixed in between that. So that is what we call the zigzag arrangement or staggered arrangement. Okay, let us find two major things in first step, that are total number of rivet per pitch. To find number of rivet per pitch, you can have a pitch line just like these, and in between these two lines we are going to find number of rivets. This thing I am already explained in my previous video. Okay, let us discuss once more. Here we have a half of this rivet and another half within this pitch line. Since it is a zigzag, we have an entire rivet over here. That means you have half plus half, one rivet, another full rivet, two rivet per pitch length, that is n equal to 2. Then we have to find number of rivet with single shear, n1 is equal to, and then number of rivet with the double shear. Here when you check with this diagram, it is easily understood that both the rivets are under single shear and there is no rivet for the double shear condition. That is n1 is equal to 2 and n2 equal to 0. I'm again advising you to check my previous video regarding how to locate single shear and double shear. Okay, that is pretty much good with step 1. We can go for step 2. In step 2, in any ordinary cases, you have to find the thickness of plate. But in this question, fortunately, we have thickness as a given data and it is given as 13 mm. So we don't have anything to do with step 2 further. Okay, we can go for step 3. In step 3, we have to find the diameter of rivet hole. It is denoted as D. There is various methods that you can use to find the diameter of rivet hole, but it is advised to use Unwin's formula whenever thickness is greater than or equal to 8 mm. In our case, our thickness is greater than 8 mm, so we can use Unwin's formula. You will get this equation from the data book, and it is given as d is equal to 6.325 root of thickness t. Upon application of value, we will get 6.325 root of 13. That means d is equal to, you will be getting 22.81 mm. And we can approximate that value as 23 mm. Dia of rivet is d1 is equal to d minus 1 mm. So since we have to put a rivet in a rivet hole, we have to take 1 mm lesser rivet, and that means d1 is equal to 23 minus 1, that is 22 mm. This is applicable for most of the rivet when the diameter d is between 12 and 24 mm, and most of the problem will be under this category. You can always minus 1 mm from the rivet hole to get the diameter of rivet. Now we can go for step 4. In step 4, we have to find the pitch. To find the pitch, we have two stages. The first one, we are going to find the optimum pitch of this joint. Optimum pitch means the pitch based on our requirement, or the pitch based on the thickness as well as other strength requirement. You can have the equation for optimum pitch from your respective data book, and I am having an equation here. I'm going to write down that equation. You have to find your own equation in your data book. Locate these equation in your data book and you can easily use it. So pitch P is given by N1 plus 1.875 N2 into pi into d square tau divided by 4t sigma t plus d. So this is a standard equation to find optimal pitch. We have these datas right here. N1 is equal to 2, then N2 equal to 0, then d is equal to 23 mm, and tau is equal to 60 megapascal. Then thickness t is equal to 13 mm, and sigma t is equal to 80 megapascal. So we can apply these into optimum pitch equation. Pitch P is equal to 2 plus this entire term become 0 because N2 is 0. So I am just putting 0 here, and pi into 23 square into 60 divided by 4 into 13 into 80. Don't forget to plus diameter 23. And upon solving, you will get optimum pitch is equal to 70.94 mm. You can go for an approximation of 71 mm. So we got a pitch based on our requirement. Here, this is the catch. This pitch is based on your requirement and it is not yet standardized. So according to Indian Boiler Act, and if you are from another country, your country has a particular standard of fixing pitch for the rivets, and you can follow that. And this standard is pretty much reconciled with international standard as well. So we have to check the standard pitch or the maximum pitch. To find the maximum pitch, you can have this equation. It's also available in your data book. The maximum pitch is equal to K1 into thickness T plus 41 mm. Okay, maybe you confuse what is the meaning of this thing. We already find the pitch, and what is this P max? P max is something is a baseline. If your value of pitch is exceeding this value, you cannot choose that. This is the maximum possible pitch that you can choose, below which you can choose anything according to your requirement, but you cannot exceed this value, because whenever you increasing the pitch more than a particular limit, it may leads to leaking of that joint or a sudden catastrophic failure. This is under consideration of certain safety, and all the countries have their own regulation and using Indian standard to solve this problem. Okay, here we have to find two values. First thing is K1, another thing T, that we have 13 mm. To find K, you have to check with your data book. Here you could find the value of K1. So on the left extreme we have number of rivet per pitch, and we found it as 2. We have 2 rivets per pitch since it is a lap joint, and we got the value as 2.62. So number of rivet 2 per pitch. For lap joint this will be 2.62. Suppose you're dealing with a butt joint, you will be getting 3.06. Okay, let us deal with this question. We have K1 is equal to 2.62. That means P max is equal to 2.62 into 13 plus 41. So you will get the maximum pitch as 75.06 mm. We have two values. The first one is the pitch and the second one is the maximum pitch. So you have to compare optimum pitch with the maximum pitch. So we have optimum pitch as 70.94. We round it as 71 mm, and the maximum value of pitch as 75. That means you could have a value of pitch up to 75 mm as per the standard, and as per your requirement you are only getting 71 mm. That means you can go for that value and your design is safe and your design is reconciled with the standard. This is the method of checking rivet. That is, if P optimum is less than that of P max, you pass the checking. Or otherwise, if P optimum is greater than that of P max, you cannot take that value. Instead of that, you have to choose the maximum value. Suppose in this problem, you're getting the value of optimum pitch as some 80 mm. So if it is 80 mm, definitely it is greater than that of P max, which is 75. So in that case, you cannot use 80 mm pitch. Instead of that, you can go for the maximum value of pitch. In step 5, you have to find the transverse pitch. Transverse pitch means the distance between two gauge lines. Here you can have this thing. This is what we call PT, that is the distance between two gauge lines. Okay, let us have an equation. PT is equal to, as per standard, 0.33 times pitch plus 0.67d. This is the standard equation. That means PT is equal to 0.33, pitch what we have 71 mm plus 0.67 into 23. Upon solving, you will get PT is equal to 38.84 mm. You can take it as 40 mm. Okay, now we can go for the step 6. Step 6, you have to find the margin of joint. Margin is defined as the distance between the extreme end towards the gauge line. So you can have the margin right here. It is marked over here. Hope you remember this specification. This is what the margin. If you want to find the margin, there is a standard equation which you can use easily. And from my data book, I am getting this equation as margin M is equal to 1.5 times of rivet hole diameter D. So here we got M is equal to 1.5 into 23, that is equal to 34.5 mm. So that is pretty much on this step. Step 7 is the last one, and it is very much important. You have to find the efficiency of joint. There is one exclusive video on this topic in my channel. If you have confusion on how to find efficiency, you have to check, and I derived these equation, and there is a clear instruction on how to find efficiency. And in this problem, we will be taking equation from the data book and directly apply those equations to get efficiency. And remember, to find the efficiency of any joint, you have to find the three efficiency and choose the lower one. Hope you remember what was those three efficiencies. The efficiency of joint eta is the least among eta T, eta C, and eta S. That is the tearing efficiency, crushing efficiency, and the shearing efficiency. So let us find each of these efficiencies. The first one is we can go for the tearing efficiency. Eta T is given by, this equation is available with most of the data books, is pitch minus diameter of rivet hole divided by pitch. This is equation. So we have 71, the pitch what we found, minus 23 by 71. Upon solving, you will get this as 0.6761. So that is, to find efficiency in percentage, you have to multiply this with 100. That is equal to 67.61 percentage. So we have eta T is equal to 67.61 percentage. So similarly, we have to find the next efficiency, what we called as crushing efficiency. Crushing efficiency is equal to, you can locate this equation in your data book. Okay, let us apply the values. C is equal to, we have N1 as number of rivet with a single shear as 2 into thickness of inner plate and outer plate is same. Since it is a equal plate lap joint, we can put T as 13 plus 0 because we don't have N2 here. N2, that is double shear value is 0. Substitute that value, you will get sigma C is equal to 0.9718. So upon percentage, you multiply this with 100. So we got the value of eta C as 97.18 percentage. There is one more efficiency that we have to find, shearing efficiency. We have the equation from data book for shearing efficiency as, upon application, N1 is equal to 2 plus there is no N2, that is 0 into pi plus 23 square into 60 all divided by 4 into pitch 71 into 13 into 80. When you solve this, you will get 0.6572. You can write this in percentage as 65.72 percentage. So we have eta as 67.2. And to find the efficiency of joint, there is a very important thing here, and you have to check all three. That is, eta S is equal to 65, 97 and 67.61, and it is obvious that we have eta S as the lowest value. We will take that as the efficiency of rivet, that is 65.72 percentage is the efficiency of this joint. So this is all about solving a design problem for lap joint. Okay, let us have a quick review on the steps. In first step, you have to identify what is the types of rivet, and then after we can go for the thickness. And the third one, we have to find two things. The first one is the diameter of rivet hole. Then after we minus 1 mm from that, we find the diameter of rivet itself. Then on fourth step, you have to find the pitch, and there is two kind of pitches. Optimum pitch, from equation from data book we found the pitch as 71 mm, and then after we have to check for the maximum pitch, and again we go for the standard. We'll take P max equal to K1 T plus 41, take the value K1 from data book, we'll get P max as a value. If P optimum is less than P max, you can choose that value. Greater than that of P max, you cannot take it. Instead of that, you have to take the P max itself. And hopefully in this problem, we don't have that issue. So we choose the optimum pitch. And on step 5, you have to find the transfer switch PT from data book. We apply the value and got the answer. And step 6, it's an easy one, the margin of join. It's a direct application of standard equation. And in step 7, we will find 3 efficiencies: eta t, tearing efficiency, crushing efficiency, and at last the shearing efficiency. And we'll check all those 3 efficiencies and choose the least among that value as the efficiency of join. So this is the process of designing any riveted join. You can follow the procedure, and if you have confusion with the equation, don't try to mug up any of these equation. You can use any standard data book to get this equation. Obviously it will be permitted to use with your examination, or if you're designing a rivet for a practical purpose, you can use any kind of data from internet as well. Okay, thank you for watching this video. I will be coming with another different type of problem. As always, thank you for watching.